Well, right now we're going to start a series on precession, which is the fact that the Earth's axis of rotation around itself kind of wobbles over a period of 25,700 years, 25,500 years kind of thing, and how some people come up with an alternate theory because they find that because gravity and rotation is too complicated for them. This is from a channel called See the Pattern, which has a lot of alternative science stuff on it. About a year ago, I think I was going to do this, but I had computer problems. I'd have to probably break it up into more parts than the 3 parts that did, because, adding my own responses to spots adds time, and I only got 10 to 15 minutes per video on YouTube. So let's get into what they have to say about precession.
That this cycle takes about 26,000 years to complete. It was first discussed by Hipparchus in about 150 BC. He used older data of the star Spica and determined that it had moved about 2 degrees relative to the autumnal equinox. He concluded that the equinoxes were moving. Unfortunately, most of his writings have been lost. There is mention of this by Ptolemy, who explained precession as the rotation of the celestial sphere. There are also claims that the Mayan long year count involved the Pleiades and may have been an effort to calculate the precession of the equinoxes. And there is also some evidence that the Egyptians were aware of this movement as well. There is clear evidence that the Indian astrologers were aware of this precession for a long
Equinoxes were moving, but what at right rate? He said it was 2 degrees. He didn't say how long that Hipparchus took the measurements back. It could have been 500 years, it could have been 1,000, it could have been 2 years. So you don't really know the rate of precession from those measurements. Oh, you also notice that he mentions the Pleiades. This will come up in another video probably. It does come up in another video of his, because they think that the sun is orbiting around the Pleiades in Sirius. No evidence of that, but that's what they believe in this model. But it's time to get back to him.
It was Copernicus who first suggested that this movement of the equinoxes might be due to the Earth spin axis wobbling. It was Newton who then assigned gravity as the cause of this. To date, there is no evidence that any of the axes in any of the planets within the solar system are actually wobbling. His initial equations never matched the actual precision rates. And so a long series of tweaks was initiated by many different people to attempt to bring the value back in line with observations. But none have ever questioned the underlying assumption. The first laws and principles of physics that any human learns, they do so before they are old enough to read, or even talk. And unfortunately, our intuition tricks us into believing it is simply a downward force. By the time we go to school and learn that gravity acts between 2 masses, it is too late and the damage is done. And even Isaac Newton fell victim to this delusion. Now, most of you have seen or used a gyroscope. Spin it up and you can easily balance it on your finger. Move your hand slightly to the side and the gyroscope will start to precess, like a wobble. And this means that the gyroscope's top axis wobbles in a circular motion while the bottom axis remains fixed. The problem with this setup is that when we examine the forces involved, it requires 2 important things. Firstly, it must be fixed at the bottom axis, and secondly, it requires the force of gravity to be acting downward. And if we remove these 2 conditions, something totally different happens. So if we examine what happens to a gyroscope in space, it will become more obvious what should actually be happening to the Earth.
I'll just get this gyroscope here, and it's just a toy gyroscope really, but of course in zero gravity, if you knock it, it's going to tumble, it's going to move around like any object up here does. However, if I get this spinning, just give me a second. So once the gyroscope is spinning, you can just see how stable it becomes. And however I knock it, it's not going to change its plane. It's going to remain in the same plane. I can put it physically into a different plane and tap it again, but it will still hold that same plane, and it's much more stable. So it just gives you an idea of how we use spin stabilization and gyro stabilization for control on board the International Space Station.
And as we can see in the video, no matter what the sideways movement is, the spinning gyroscope stays in the same orientation no matter what the force is. Newton believed that the precessional wobble was caused by the fact that the Earth bulges at the equator, so it's not a perfect sphere. And at the same time, the Moon orbits around the Earth and orbits around the Sun, and that the combination of the forces of the Moon pulling on part of that bulge and the Sun would cause a wobble force to be initiated on the Earth, causing it therefore to wobble.
There are actually, he mentions that other planets don't have precession of the equinoxes, but that's untrue. Mars has one that's 173,000 years long, and Jupiter's about 1,200 years long, just for a couple of examples. So they do have them. So I don't know if Gareth actually looks up things that are contrary to his theories, but that just took a quick Google search. Also, factors in the precession of the planet includes other planets and asteroids. That's why they keep on one of the reasons they have to keep on resetting it. But other factors, even probably a lot of our artificial satellites nowadays probably affects the precession. But one method is the slingshot method to accelerate satellites to get them further out, and that probably affects the precession of the planets. So that's why they have to constantly recalculate it.
But as we can see in the video, no precession is set up at all. The gyroscope remains perfectly aligned in the same orientation no matter what forces are applied to it. Now, as time went by, observations started to appear which would indicate that something other than precession was happening. So let's examine some of the biggest issues with precession. So number one, if we examine the equations that are used to calculate this, we will see that they are based on a mathematical formula and not on the mechanics of how the solar system works. And this formula only works when the starting point is pinned at a very specific date. And it is only accurate for a short period of time. So if we were to scale this up into the hundreds of thousands, if not millions of years, the time that it would give you for precession would become more and more inaccurate. So this means that as we move through time, they are having to tweak this formula all the time to account for the discrepancies in the observations compared to the equation that they are using. Number two, Crittenden realized that if the Earth was precessing due to the gravitational tug of the Moon and the Sun, that it should cause a slow shift in the timing of our seasons. But looking at historical records, we can see that the seasons have not changed over our recorded history. So in order to fix this problem, they had to actually fix the equinoctial point. It rotates around the sun, and it takes 365 days to do that. It takes a full year to complete one orbit. From when we start, so let's say that it is the summer solstice, then you would know that the sun rises in a particular point. That point means that the Earth has to be facing that same point, and then as it moves around the orbit, when a whole year is complete, it would once again face the same direction. So the equinoctial point is fixed at that point. It is always 360 degrees. So as the Earth moves around the sun, it would effectively rotate 360 degrees. Now realize that the Earth itself obviously rotates every day on its axis, but every day it has to rotate a little bit further in order to keep facing the sun. Imagine as you're going around the curve, as the Earth turns, it has to every day turn a little bit further. So therefore, every year would not rotate a full 360 degrees in its orbit. It would only rotate 359 degrees and whatever else, the 10 seconds, whatever it is. So it meant that every year, the point at which it was facing back would be a little bit further on, and then the next year a little bit further on again, until it completed the full cycle, and back it was. And using this, it fitted back in. So if they use this model, then the seasons would no longer move. The problem was that when we then observed the lunar cycle, then if we use this to calculate Earth's orbit, it shows that it does actually follow a 360 degree path. And in fact, if it followed the other path, so if they indeed fixed that point, then we would see changes to the lunar cycle, which we don't see. It's pretty regular, like a clock. So we are back to the same problem, that this does not show that the Earth itself wobbles due to precession.
The moon orbits around the Earth, so it's gravitationally bound to the Earth, and so it makes one rotation around the Earth in 27.3 days or 28.3 days. Or 20. It's probably not going to show precession because it's not because the Earth is also rotating, and it's always, so it's stuck. But so that's probably why it doesn't precess. But yeah, the points in space relative to us change over time. Okay, it's almost time, hitting my limits, so thank you for listening. I hope you enjoy it, and I hope somebody found this enjoyable and liked it. Goodbye. And, oh yeah, of course, like and subscribe if you want to. Bye.